In graph theory, we say that a graph H is a vertex-induced subgraph of another graph G if it has a subset of vertices from G and includes all edges between the selected vertices as they exist in graph G. So let's take a look at an example. Let's say we have graph G right here. I've created 4 other graphs. Let's determine if each of these 4 graphs is considered a vertex-induced subgraph of G or not. So if we consider this first graph right here, we can see this graph has 4 vertices, A, B, C, and D. Each of these vertices exist in the original graph G. We can also see that each of the edges that exist in this graph also exist in the original graph G. So because all the vertices and all the edges in this graph also exist in the original graph G, we would say that this graph is considered a subgraph of G. But to be considered a vertex-induced subgraph, it means that each of these vertices in this graph should be connected by all of the edges that they're connected by in the original graph. So if we just consider these 4 vertices, if we consider them in the original graph, we can see that these 4 vertices are connected by a total of 4 edges right here. And we can see that in this graph, they are also connected by the same 4 edges. So we would call this graph a vertex-induced subgraph. Now the notation that we can use to indicate that is we can write G, so the original graph with brackets, and then we just list out the vertices that are included in this smaller graph. So we can say A, B, C, and D. So the way that we read this notation is we say this graph is a subgraph of G induced by the vertices A, B, C, and D. So again, this graph is a vertex-induced subgraph of graph G. All right, now let's check out this second graph right here. So again, we have vertices A, B, C, and D, but we'll notice that B and D are not connected by an edge right here, and they are connected by an edge in the original graph. So this graph does contain a subset of the vertices of graph G, and it contains a subset of the edges of graph G, so it is a subgraph, but it is not considered a vertex-induced subgraph because we're missing one of the edges right here that exists in the original graph. So for this one, I'm just going to write no to indicate that no, this is not a vertex-induced subgraph. All right, now let's consider this next graph right here. We can see it contains 4 vertices, A, C, D, and E, each of which belong in the original graph G. So if we only consider these 4 vertices, we can see that there are 1, 2, 3 edges that are connecting these particular vertices in the original graph, and we can see that all of these edges exist in this graph down here. So because each of these vertices is connected by all of the original edges that they're connected by in the original graph, we would say that yes, this one is also a vertex-induced subgraph. And the notation that we can use to describe it is, we can say that it is induced by vertices A, C, D, and E. So again, this one is a vertex-induced subgraph of the original graph G. All right, now let's check out our very last example here. Let's consider this graph. We have vertices A, C, D, and E, which all belong to the original graph G, but we'll notice that the edge that connects D and E in the original graph right here, it's missing from this graph. So because these vertices are not connected by all of the edges that they're connected by in the original graph, this is not a vertex-induced subgraph. So for this one, I'll also write no, not a vertex-induced subgraph. So those were just a few quick examples of how to determine if a graph is a vertex-induced subgraph or not.